Hello everyone, my name is HPena. I teach the 7th and 8th grade accelerated math course, which is new to Texas this year. And I teach the 8th algebra blended course, which teaches both 8th and algebra courses in 1 year. For this particular redesigning activity, I am focusing on my 7th and 8th grade accelerated course because, again, it is new and we just did this activity on Friday. And so I wanted to go back and just break it down. And of course, I use the Harvard Project Zero thinking routine for this analysis. So let's go ahead and dive in. So here is my original task. And I know you might be thinking, wait, why are you really doing probability? If you did the 7th and then the 8th grade course, since it's new, we created our own curriculum in my district for this particular brand new concept because the state pretty much left it vague. They just told us what to cover but not how to cover it. And so we decided to do a vertical alignment in ours. So we took knowledge that the kids have from 6th grade, so then we can then from there build on it to 7th grade, and just tweak some concept that rate. We turn it into slope in 7th, or rate of change, and then from rate of change to slope in 8th grade. And so that's how we built, so we can understand the 8th grade concepts. But now that the 8th grade standardized testing is done, we need to go back now and teach the stuff that we cut out, that is just pure 7th grade. And so probability is one of those units that they don't use in 8th grade, but they will see again in algebra next year when they have to take their TSI exam at the end in May. So now that I did the activity and I kept it service level because it's fun, now I feel guilty that I did that because it's gonna affect them if they don't have that conceptual understanding. So, you know, now I need to go back and probably reteach it on Monday because this analysis sort of put me on a guilt trip. But anyway, so this is the original task I selected. It's a Skittle lab, which is used to teach theoretical and experimental probability. So in this activity, students follow a set of structured steps, including counting outcomes, calculating probability, and then conducting repeated trials, which are explicitly told to them, and they tell them exactly how to do it. So while the task is hands-on, it is mainly procedural because students are following directions rather than making decisions about the mathematics. As a result, it represents a medium to low cognitive demand task, since students are applying procedures without explaining their reasoning or exploring multiple approaches. So again, although the task is hands-on and uses raw data, it is still highly structured and it limits student thinking. We tell the students exactly what to do, including how many trials to run and how to record their results, which means they are just following procedures rather than making those mathematical decisions. According to Clark and Roche, the types of tasks students engage in determine the level of thinking, and overly structured tasks reduces opportunities for reasoning and justification, which this lab does exactly that. As a result, students may complete the activity without fully understanding what both of the theoretical and experimental probability differ. So this shows that while the task is engaging, which is again was really the focus of Friday's lesson, it does not promote deeper conceptual understanding, which highlights the need for redesigning. So that's exactly what I did, and I'll probably go back and present them with the second project, which is that carnival activity that I did, my redesign. Here it is. So I redesigned this task into a carnival game challenge where students then create their own probability based game. Instead of following steps, students decide how the game works, what counts as winning, and how likely those outcomes are. They calculate theoretical probability, they run the trials to collect experimental data, and then compare the results. Students will use the Harvard Project Zero routine thinking, the claim support question, to determine whether the game is fair and then support their reasoning with evidence. This redesign shifts the tasks from procedural to conceptual by requiring students to make decisions, explaining their thinking, and then analyzing outcomes. So I wanted to, bring back what we learned last week in our synthesis of our articles, which is that procedure fluency and conceptual understanding should be intertwined. And so, unfortunately, the skill labs just completely, untwined the conceptual, and so this redesign will go ahead and intertwine them again. So this redesign is grounded in research from Bowler, Clark, and Roche, and then of course the Harvard Project Zero. Clark and Roche in 2018 explained that the mathematical tasks students engage in directly determine the level of thinking, which is why redesigning this task increases cognitive demand. Bowler emphasizes that deep mathematical thinking occurs when students engage in open-ended tasks that allow multiple approaches and requires explanation rather than memorization. So in this redesign task, students create their own carnival game, which requires them to make decisions, then go on test ideas and justify their conclusion, like I explained. Additionally, the claim support question routine from the Harvard Project Zero, routine thinking supports students in explaining their reasoning and then using the evidence to evaluate whether the game is fair. So overall, these changes transform the task from a procedural activity into a meaningful mathematical investigation that promotes reasoning and then, of course, the main goal, which is that deeper understanding. The redesign task shifts students from simply completing steps to actively thinking about probability. So instead of just calculating answers, students design their own, carnival game, make predictions, and then compare the theoretical and the experimental results. This helps our students develop a deeper understanding of how probability works in real situations and why the results may differ. Because the tasks require students to justify their thinking using data, it also supports stronger reasoning, and then, of course, it improves their communication skills, which is vital. In my future teachings, which again will be on Monday, I will continue to redesign procedural tasks, or starting Monday, excuse me, I will continue to redesign procedural tasks into more meaningful, open-ended problems that require students to explain their thinking and apply mathematics in real-world context. Thank you for watching this redesigned activity. Here are the references, and of course, I'll see you next week like always. Bye bye.